Okay, there's a little red footnote here. I hope you're not confused by these footnotes, but the footnote says I'm changing the problem to a similar problem because it was identical to problem 30. Now, I haven't watched the video of the guy that did this. He might have changed it too, I don't know, but I'm changing the problem. This is problem number 80, by the way. And it certainly looks like number 30. It actually, you know, if you're working on these problem sets, you might say, this looks familiar to me. And what I mean by that, this has something to do with a geometric series, all right? So I don't see it immediately. So what I did was I wrote down the geometric series for you, all right? And that's right over here. And there's one or two things you could do with it. You could integrate or differentiate it. I differentiated it. And the derivative is pretty easy, by the way. For example, the derivative left side, this is 1 minus x to the minus 1. When you differentiate that, what do you get? You get minus 1, 1 minus x to the minus 2, times minus 1. So you're going to get 1 over 1 minus x squared. Relatively simple. And this guy also really simple to differentiate. What do you get? First one's going to be 0, then you get 1, then you get 2x, 3x squared, yada, 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 yada. Really simple, all right? Then the next thing I did, like I did in problem number 30, was I set x to be a half, all right? So I do this over here. So someone says, why would you have done that? I'm kind of looking in the problem, and I'm seeing the 2 there. So I think it probably has something to do with a half. So I plug it in, and lo and behold, when you do that, again, I want to point out, when I plug in a half over here, what do I get? I get 1 over 1 minus 1 half. That's quantity squared. And that's going to be 1 over, well, 1 minus 1 half is a half. And when you square that, you get a quarter. So that's going to be 1 divided by a quarter, which is just simply the number 4. Relatively simple. And over here, I plug in a half. And when I do that, I'm careful about it. I'm not going to do any simplifications. I just write it down. When you plug in half, what do you get? 1. That doesn't change. Then you get 2 over 2, 3 over 2 squared. And then you get 4 over 2 cubed, so forth and so on. Very predictable. That's what those dots are indicating over here, all right? The next thing I did, because I really don't see what I want to see, and someone says, what do you want to see? I want to see this over here. I'm not seeing it yet. So what I did was I multiplied both sides by 2. And if you do that, well, 2 times 4 is 8. And I'm doing 2 times this as well. And what is it going to give you? Well, it's going to give you 2. There's a point to this. 2 times 1 is 2. I'm not doing anything at the tops. And the reason for that, I'm kind of reducing this. So it's going to be 2, and then 2 to the 0, 3, 2 to the 1, 4, 2 cubed. Whoops, there's a mistake. Oh, no, I'm sorry, not a mistake there. But anyway, very predictable pattern. What I mean by that, you could write the sum down, all right, for this. Now, when I write the sum down, before I do that, I'm going to take 2 from both sides. And when you get 6, and then I'm going to look at this thing. And I think that's what I wanted. So someone said, what do you mean that's what you wanted? Let's write this down now. This looks like, and let's write this down over here. I'm going to say it looks like, you know, if I just look at the top, and I do want to start, let's look where they started. They started with 1. I do want to start at 1. So I write this over here, n equals 1 to infinity. And I want it to look just like that I got over there. What's it going to be? It looks like n plus 1. And why do I say that? Look at the top. It's 2, 3, 4, blah, 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 blah. What's the bottom going to be? 2 raised to a power. And what's it going to be? Well, it looks like n minus 1, because we want the 0, then a 1, and then a 2. All right? Is that the series we wanted? Let's go back over here. That's the series we wanted. N plus 1 over 2, n minus 1. Do I know the sum of that series now? I do. It's 6. How'd I do that? Recognize that it's something to do with geometric. And, you know, I differentiate or integrate to help myself. How about that? Thank you so much.